Hello, my name is Jack Menard. I am the Program Director at ARPA-E's agency. This presentation gives an overview of the repair project and outlines expertise needed for the project. Repair addresses legacy pipeline infrastructure used by gas utilities. We have a workshop in Washington, D.C. on October 10th and 11th. I'll be discussing the technical requirements for the project and the topics that will be discussed at the workshop. Repair stands for Rapid Encapsulation of Pipelines Avoiding Intensive Replacement. Gas utilities started using cast iron pipes in the late 1800s and switched to bare steel pipes in the 1930s. The graph shows that gas utilities replaced many miles of these legacy pipes. However, there are still several thousand miles of larger diameter pipe that is the target of this project, both cast iron and steel pipe. Several companies have commercialized in-situ repair technologies for pipes. The goal of this project is to build on this experience and incorporate advances from outside the pipeline world to create a smart composite pipe inside the old pipes and reduce costs and disruptions compared to excavating and replacing pipes. Before getting into repair, I'd like to introduce ARPA-E. We are part of the Department of Energy, created 10 years ago to accelerate commercialization of new energy technologies. ARPA-E seeks out impactful projects that have a high degree of technical risk. We provide early-stage funding to support commercialization, essentially de-risking new technologies. We set very aggressive performance targets for our projects, and as a consequence, these projects tend to be rather complicated and require a team to solve the problems. There are several core principles for ARPA-E projects. First, we seek disruptive technologies that establish an entirely new cost curve or trajectory for a technology. So we're not really interested in incremental improvements to existing technology. Second, we actively seek solutions from outside the existing commercial space. For example, in this program on natural gas pipes, we're pulling in expertise from water and sewer, marine biology, additive manufacturing, prosthetics, defense, and aviation composite formulations and testing. And finally, we promote teams. We recognize that surprising breakthroughs happen when parties with domain experience in one area interact with experts working in other areas, cross-fertilizing existing solutions with new approaches. I'd like to discuss how we see ARPA-E's approach playing out on this project. As I mentioned, there are several commercial in-situ pipeline repair technologies available today. Our intent is to build on this experience, creating a smart composite pipe in a pipe that is superior to the properties one obtains by replacing legacy pipe with new plastic pipes. We have several constraints. First, we want the process to run while the pipes are live, and we want to work our repairs with minimal cleaning of the old pipes. We also need to inspect the old pipes before and after rehabilitation. During these steps, we want to collect data to create 3D maps of the pipelines, incorporate inspection results for the original pipe and for the new composite coating. This information needs to be available real-time to support decision-making by the technicians who are operating the equipment. It also needs to be retrievable so it can be referenced in conjunction with future inspections or maintenance work by the utilities. Finally, for this technology to be a commercial success, we need to validate that the pipe-in-pipe approach that we are taking on is better than new pipe for the utilities, the state regulators, and the federal regulators. Our goal is to have the rehabilitated pipes using this technique qualify as new assets for utilities so that they can be included in the utilities' assets for rate-based calculations. This provides a cost recovery method for the utilities to use the technology. So what are the benefits of this intended approach? First, the project is intended to provide lower costs. Second, less disruption. And third, a superior product for the utilities and their customers. I should mention that while this program is focused on gas utility pipes, the same technology can be adapted to other critical pipeline infrastructure, including sewer, water, gas lines for transmission and gathering, each of which itself is a multi-billion-dollar market. For this project to be successful, I mentioned before, we require a diverse set of skills and teamwork. This slide is intended to show how the teamwork, communications, and coordination will be managed through this process. ARPA-E recognizes the importance of teams, coordination of effort, and communication. You can see that there are several major groups that are going to be required to accomplish the goals of this project. The Technical Steering Committee sets performance specifications to allow rehabilitated pipe to be considered a new asset. This is basically the voice of the customer coming from the utilities and their regulators, telling the other members of the organizations what properties are going to be essential for the pipe to qualify as a new asset. The specifications from the Technical Steering Committee need to get translated into performance tests and models to validate an expected life over 50 or more years of service against failure modes that will be defined by the Technical Steering Committee and the testing organizations. The testing organizations will provide performance test metrics so that we can ensure that the properties that are necessary to meet the regulators and the utilities' approval can be hit. These performance test metrics are then communicated to the system component developers, and it's their responsibility for meeting the metrics. Finally, the service companies are required to integrate the components into a turnkey commercial offering that is ensuring that will meet the performance targets set by the regulators and the utilities. So we can see that there's four major groups. Some organizations actually have capabilities in two or more of these areas, but we're looking for parties who can contribute to any of these areas. And as you can see, pulling together all the components into a commercial offer will require a lot of communication and coordination amongst these four types of organizations. Let's talk specifically about each type of diverse technical experience that's required. First, we'll start with the Technical Steering Committee. The Technical Steering Committee is intended to represent the voice of the customer. Their input is critical for approving the smart composite pipe and ensuring that it qualifies as a new asset for utilities. Representatives from PHMSA, Department of Transportation, state regulators, representatives for codes and standards, and the utilities have all agreed to participate to date. We are actively seeking additional representatives from utilities and encouraging them to get their state regulators engaged as well. The representatives of the Technical Steering Committee will be speaking at the workshop. I mentioned that there are already commercial offerings available in this space, and we intend to build upon those. I'm going to be highlighting some of these as examples. It does not constitute an endorsement of their organizations or their technologies. It's only intended to provide a reference point. A good example is in the testing area. For new pipes that go into the ground to replace old pipes, there are PHMSA rules, codes and standards, and well-accepted testing protocols. None of this exists today for a composite pipe in a pipe, which is a new technology. So we will need to develop these protocols for our technology solution. This program will need performers to translate system specifications into material properties. They will then need to develop test methods and models, run the test, and provide timely feedback to the teams developing system components. At the workshop, we will be discussing work by Cornell to qualify two other alternative pipeline repair technologies. We need robotic tools that can operate inside live pipes. The robots are required to apply the composite coating and carry inspection tools. They also need to integrate tracking devices which can create 3D maps of the pipes with accurate records for defects and coating quality control information. The pictures show example of commercially available robots. The one at the top is a robot that can deposit a composite coating inside a pipe, and the one at the bottom shows a crawler carrying inspection tools. There are diverse sets of robots, and we'll be reviewing the status of robot technology at the workshop as well. Composite coatings are at the heart of the project. We are looking to the composite to actually form the backbone for the pipe and pipe. We're looking beyond sealing the pipe and just providing mechanical strength. We're interested in enhanced adhesion and smart features such as self-healing properties and structural health monitoring, which can be incorporated into the composite. Essentially, we are looking to have a superior pipe solution to just plain polyethylene that's installed today. It's also important that the coating is compatible with robotic tools for deploying the coating and inspection tools to validate its integrity. And we'll be talking about smart features and the inspection tools also at the workshop. As I mentioned, we need inspection tools to validate the integrity of the coatings as well as the underlying metal pipe. It's important to note that we cannot hydrotest the pipes after we apply the coating, so we will need to rely on physical measurements plus correlations from the test development efforts to ensure that the rehabilitated pipe meets all its performance expectations. All this information with regard to tracking locations and integrity measurements of the pipe needs to be synthesized in real time to allow operators to make real-time decisions. This requires extensive data management and visualization expertise, and we'll be hearing from companies who provide those examples, who will provide examples of data management for utility systems also at the workshop. Finally, we need service companies that can integrate the components and provide turnkey offerings to gas utilities. The individual system components are absolutely critical, but the business model for utilities is such that they look for third-party service companies to provide basically turnkey, lump sum, rolled-up solutions. And so it's going to be essential for the service companies to be able to internalize the developments that are being offered here and roll those up into a financial offering that meets the utility's specifications. And we will have several service companies at the workshop as well. I hope this WebEx provides background for you to assess your organization's fit with our project. Please consider joining us at the workshop in Washington, D.C. on October 10th to 11th. The workshop runs from noon on the 10th to noon on the 11th, so there's time to travel on both days, both in and out of D.C. Please feel free to contact me with questions, and thanks for your time and interest.